Hello everyone, welcome to this video. In this video, we are going to explore quartiles, which is the measure of position. First, we are going to define quartiles. Quartiles are the values that separate the data into four or approximately four equal groups. So if we have a data set ranging from the lowest value up to highest value, we want to divide this data set into four equal parts. That means we want to have 25% here, 25% here, 25% here, and 25% here. In order to do that, we need three numbers for that. We need a number here, we need a second number here, we need a third number here. So these three numbers, the first number, the second number, the third number, that divides the data into four equal parts, these numbers are called the quartiles. The quartile which is here in the middle, it is called the second quartile or median. So median is the second quartile. So what we need to do is, in order to find the quartiles, first we arrange the data in ascending order, then we find the median, that is your quartile. Then after that, in order to find Q1, we find the median of the data below the median. That will be our first quartile. And in order to find the third quartile, we find the median of the data above the median. That will be our third quartile. So after we know the definition of the quartile and the simple steps in calculating the quartiles, we are going to look at the example on how we can find the quartiles. Okay, here is the example. Collision coverage insurance against physical damage paid in dollar by an insurance company for a sample of 18 collisions are given here. These are the amount paid in dollar. We have to find the quartiles Q1, Q2, and Q3. Here we have 18 number of observations. So in order to find the quartiles, first we need to find Q2. So in order to find the Q2 divides the data into two equal parts. You have 18 observations, meaning of that is we need 9 observations below Q2 and 9 observations above Q2. So you can see here, from here up to here we have 9 observations. The data is already arranged. And after that, here we have the 9. So your Q2 is in between the value 1165 and 1953. So meaning of that is Q2 is equal to, so your Q2 is the average of these two values, 1165 and 1953. So we add 1165 and 1953 and we divide that by 2. So if we add those two values, you get 3118 and we divide that by 2. 3118 divided by 2 is 1559. So $1559, that is the second quartile or median. Now we also need to find Q1 and Q2. So Q1 is the median. Okay, Q1 is the median of the values less than Q2. These are the values less than Q2. We have to find the median of that. So these are the values less than Q2. Okay, values less than 1559. These are the values. So we have to find the median of that. So in order to find the median, here we have the 9 observations. So in the middle of 9, we'll have the fifth value, 1, 2, 3, 4, 5. By doing that, you'll have 4 observations this side and 4 observations this side. So this is your Q1. So your Q1 is the median of the values less than Q2. So in this case, it is $735. $735. And then Q3 or third quartile is the median of number more than Q2. The numbers more than Q2, these are the numbers more than Q2. Here we have 9 of them. So in the middle, we have 4,668. So that is Q3. So Q3 is 4,668. So it is quite easy to calculate the median, all we have to do is we have to divide the arranged data set into 4 equal parts. And in order to divide the data into 4 equal parts, we'll have 3 numbers. So you can see here we have 4 numbers below Q1, 4 numbers above Q1, and then we have Q2. Then after that, we have 4 numbers up to Q3. Then after that, we have 4 numbers. You can see that our data set is evenly divided. So by doing that, these 2 numbers, Q1 and Q3, they are already there in the data set. Q2 was not there, so it was the average of 1165 and 1953, which is here. So that is the first example on the calculation of quartiles. Second example, for the following set of data, we are asked to find the interquartile range, sometimes referred to as IQR. Interquartile range is third quartile minus first quartile. We are asked to find the interquartile range and mid-quartile. Mid-quartile is the average of third quartile and first quartile. So interquartile range is the difference between third quartile and first quartile. Mid-quartile is the average of third quartile and first quartile. So you can clearly see, in order to calculate interquartile range or mid-quartile, you need Q1 and Q3. So first we are going to find Q1 and Q3. So if you look at this data set given here, this is not arranged. You can see I have 51, then 58, back to 50, then 56, 57, 59, back to 54, 60, and again back to 52. So first we need to arrange this data in increasing order. Okay, here we have the arranged data. We have 9 observations, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is the 5th one, which is 1, 2, 3, 4, 5. This is the median, or Q2, but we need Q1, which is the median of these numbers, and Q3 is the medians of this number. So Q1, you can see here we have 4 observations. So the middle value will be in between 51 and 52, which is obtained by 51 plus 52 divided by 2, which is equal to 51.5. And your Q3 is the median of the numbers which are here. So the middle value will be here, which is between 58 and 59. So it will be 58 plus 59 divided by 2, which is 58.5. So now we have Q1 and Q3, so we can easily find the interquartile range and mid-quartile. So let's do that. Now the interquartile range IQR is equal to Q3 minus Q1. Q3 minus Q1. Your Q3 is 58.5. 58.5 minus Q1 is 51.5, which is equal to 7. That is IQR. And the mid-quartile now, mid-quartile is this one, half times Q3 plus Q1. So half times Q3 plus Q1, which is equal to half times Q3 is 58.5 and Q1 is 51.5, which is equal to half multiplied to 58.5 plus 51.5 is 110, and half of 110 is 55. So that is the mid-quartile. Note one thing, in the given data set, we observe that the median Q2 is 56. So Q2, the median and mid-quartile are not the same. Sometimes people get confused with these two values. They are different. Mid-quartile is different from median. So this is the second example on quartiles. Now we are going to look at the third example on quartiles. Okay, here is the third quartile. And in this example, we are asked to, third example on quartile, and in this example, we are asked to find the outliers in the following data. So when we say outliers, outliers are any value which are extremely lower compared to the given data set or extremely higher when compared with the given data set. Or in simple sense, we can say any value, let me write, any value less than the first quartile minus 1.5 interquartile range or IQR, or any value more than third quartile plus 1.5 times IQR, they are called the outliers. And these values, 1.5 Q1 minus 1.5 IQR and Q3 plus 1.5 IQR, these are the fences. This one is the lower fence. This is called the lower fence. That is, any value less than this is outlier. And this is called the upper fence, meaning of that is any value more than this is an outlier. So this is upper fence. So we can clearly see if we want to find the outlier, we need Q1 and Q3. And using Q1 and Q3, we can easily find IQR. So here we have the data set given, and this is already arranged. The number of observations are 1, 2, 3, 4, 5, 6, 7, 8 observations. So to find Q2 or median, we need 4 observations on this side and 4 observations on that side. So here you will have your Q2 or median, which is the average of 13 and 15. So it is 13 plus 15 divided by 2, or your second quartile is equal to 13 plus 15 is 28. 28 divided by 2 is 14. Now Q1 is the median of numbers less than that. So it is the median over here. That's your Q1, which is the average of 6 and 12. So it will be 6 plus 12 divided by 2. So Q1 is equal to 6 plus 12 is 18. 18 divided by 2 is 9. Q3 is here, is the median of the numbers more than Q2. So here will be the median. 2 below that, 2 above that. So that is the median. And in this case, this is Q3, which is equal to 18 plus 22 divided by 2. And 18 plus 22 is 40, divided by 2 is 20. So we got these values, Q1 and Q3. Also, we need IQR. Let's find that. So IQR is the difference between the third quartile and first quartile. Third quartile is 20 and the first quartile is 9. That is equal to 11. So we have everything ready. We have Q1, we have Q3, and also we have IQR. So let's find the lower fence and upper fence. So now, lower fence is Q1 minus 1.5 IQR. Q1 is 9 minus 1.5 times IQR is 11. So if we simplify that using calculator, that is negative 7.5. Similarly, upper fence is equal to Q3 plus 1.5 times IQR. So Q3 is 20 plus 1.5 times IQR is 11. And if we simplify this using calculator, we'll get 36.5. So if we see any value less than negative 7.5, that's an outlier. So when you look at the data, we don't have anything less than negative 7.5. So we don't have outlier which lies below negative 7.5, or we don't have any outlier over here. Upper fence is 36.5. If there are any data value more than 36.5, those numbers will be the outlier. So in this case, we have 50, which is more than outlier. So 50 is above the upper fence, so it is an outlier. Okay, that is the end of the third example on quartiles. So with this, we completed this short video on measure of position involving quartiles. Thank you so much for watching. I hope this is helpful.